the beginning of today's notes asks you to graph 1 over x, y equals 1 over x, just to see what happens. And you don't actually have to do this. I'll just graph this for you. We get this weird little, it kind of looks like a heart monitor blip. There's two pieces to this. There's two curves that are both C-shaped. And there is an asymptote, a vertical asymptote. So like the left side of this kind of looks like a log graph. There's a vertical asymptote down the middle. There's also a horizontal asymptote horizontally through the middle. So this creates two separate asymptotes, both a vertical and a horizontal asymptote. All rational functions of this form, y equals a divided by x minus h plus k, are called hyperbolas. They create this C-shaped, double C-shaped with two asymptotes graph. Basically, if x is on the bottom, if you have something divided by x, so the reason that this comes after section 7.1, in 7.1 we looked at inverse variation, y equals something divided by x. If you put that into a graph, it creates this shape of a graph. So here's a couple of them graphed for you, and we're going to look at where the asymptotes are. So I'm going to draw the asymptotes in to help you. On this one, there's a vertical asymptote there, and a horizontal asymptote here. The vertical asymptote is x equals 3. Take a look at the equation. Do you see where maybe that 3 comes from in the equation? If we've got x equals 3, what do you see right here? Minus 3 on the bottom. If you were to plug that 3 in, what is 3 minus 3? 0. Can you do 2 divided by 0? No, that's like a massive rule in math. You can't divide by 0. So an x value of 3 creates this situation that's mathematically impossible, and that's why there's a vertical asymptote. That's why there's no points there. So our vertical asymptote is x equals 3, and that comes from the bottom of that fraction. The horizontal asymptote is y equals 4. Where in the equation do you see a 4? The plus 4. Basically, if that plus 4 wasn't there, the asymptote would be right at 0. When I graphed this just 1 over x, do you see how there's a horizontal asymptote at 0? That plus 4 moved the graph up 4, making that horizontal asymptote at y equals 4. Okay. Domain and range for these graphs is the easiest you've ever seen. It's not all real numbers because there's definite things that x and y can't equal. So the domain is all real numbers except x can't equal 3. And the range is everything except y can't equal 4. So you use the equal sign with a slash through it to say, there's an asymptote at 3, so our x values can't be that. There's a horizontal asymptote at y equals 4, so our y values can't be that. So definitely notice that the vertical asymptote is linked to the domain, and the horizontal asymptote is linked to the range. Hopefully we now can look at number 2, and maybe we can figure out number 2 without looking at the picture. If you look at the bottom, what do you guess the vertical asymptote is going to be? What number would make the bottom equal 0? -3. And if we check here at -3, why, yes, indeed, there is an asymptote there. So we have a vertical asymptote at -3 because that's the value that would make the bottom of the fraction equal 0. Horizontal asymptote, any guesses? Y equals -1. So let's check. Why, yes, there is a horizontal asymptote there at y equals -1. Once we've identified the asymptotes, what's the domain? X can't equal -3, range y can't equal -1. All right, so from this we can conclude that the vertical asymptote is going to be x equals h, because h minus h would make 0 at the bottom. And the horizontal asymptote is going to be y equals k, that number that is added after the fraction. Okay, for the most part today, I want you to be able to identify the asymptotes and the domain and the range. And from that, you usually will be able to pick out the correct graph. The other thing that I want you to notice, in number 1, do you see how it's like this fraction is positive? There's no negative in front. The graphs are usually top right, lower left. So the right half of the graph is usually in the top right. But in number 2, see how there's a negative in front of that one? That flips it. That's why it's left, upper left, and lower right. That's something that you'll probably notice later. But there is going to be a matching on your assignment. If you know the asymptotes, you're really close to picking the correct graph, and then you can narrow it down after that. Okay, back in the day, I made my students graph these by hand. We can use Desmos to help us, so I'll show you that. But the biggest part today is, what's the vertical asymptote? VA for vertical asymptote. What's the horizontal asymptote? What's the domain? And what's the range? So here's this graph. What do you think the vertical asymptote is? X equals -2. And the horizontal asymptote is y equals -4. So we can draw that in. We've got a vertical asymptote at -2. We've got a horizontal asymptote at -4. If we want to put this in Desmos, we just have to be a little bit careful how we type it in. So I've got y equals, oops, I need to click in here so it knows that I want to type something in. Y equals, I'm going to hit my division key first to create a fraction. Or if you were using this keypad, you could hit, is there a fraction button? I don't think so. You just hit the division button and it creates that fraction for you. Then on the top, I can type the 1. On the bottom, I can put the x plus 2. And then outside of that, I need to put the -4. So this is actually really easy to type into Desmos. If you're trying to type this into a graphing calculator, it is a little bit more complicated. And this shows us the graph. But remember, if we want points to put on a graph, we need to click the settings wheel and then convert to table. Notice when the x value is -2, it says undefined, because -2 was our vertical asymptote. What I'm going to do is I'm going to pick like 2 points on the right side, 2 points on the left side, and then call it good. So if I go back to this picture, my x asymptote is -2, so I'm going to pick -1 and 0. -1 and 0 are the x values on the right side of that asymptote. I'm also going to pick 3 and 4. So 2 values on the right side of that vertical line, 2 values on the left side. And then Desmos can tell me what those numbers are. Make that -3 and -4. So I'm looking at -1 and 0, the 2 x values on the right side of that asymptote, and -3 and -4, the 2 values on the left side of that asymptote. In Desmos, -1 is already in there. We have -3. 0's in there, -3.5. I don't see -3 or -4, but you can go to the bottom of this table and type in -3, and then you can type in -4, and it will give you those values. So -5 and -4.5. So here's those points graphed. If you didn't see this in Desmos, you'd be looking at these 4 points going, how in the world is this supposed to help me? But we saw it on Desmos, which might make it a little bit easier to draw in. Basically, you just curve toward the asymptote, curve around and toward the asymptote, toward the asymptote, toward the asymptote. Just make sure you keep the graphs in their little quarter of the paper so that they're not crossing those asymptotes. Don't forget to do the domain and the range. Domain, x can't equal -2. Range, y can't equal -4. That was type 1. On the next page, you're going to see type 2. Type 2 is where there's an x on the top and the bottom, and there isn't something added or subtracted after. So we need to figure out, where does this vertical asymptote come from, and where does this horizontal asymptote come from? So the vertical asymptote is x equals -4. Where does that -4 come from? It still comes from the bottom. So that at least is the same. We know that the vertical asymptote is where the bottom would be 0. So we know our vertical asymptote, which means we also know that our domain is x can't equal -4. Our horizontal asymptote is y equals 2. I'm going to circle like this. There's a 1 in front of this x on the bottom. 2 divided by 1 in that equation is what is giving us that horizontal asymptote. So take the numbers in front of the x's, top divided by bottom, that's going to give you your horizontal asymptote. So our horizontal asymptote here is 2, which means our range is y can't equal 2. So let's take a look at the next one. Vertical asymptote. What number would make the bottom equal 0? +2, so our domain is x can't equal 2. For our range, there's a 1 in front of the x on the bottom. We do -3 divided by 1. So our horizontal asymptote is -3. And we can go in here and check. And yes, that looks like the horizontal asymptote. So y can't equal -3. Okay, this one looks a little bit different, but it's okay. Our vertical asymptote is 3 because 3 minus 3 would give us 0 on the bottom. Our horizontal asymptote, there's a 1 in front of the x on the top. There's a 1 in front of the x on the bottom. 1 divided by 1 is 1. To pick points for our table, find your vertical asymptote. That's 3. We want 4 and 5. And then we also want the left side. We want 2 and 1. It's totally okay if your table is not in numerical order. That table is just a place for you to record points. So now go to Desmos and put this thing into Desmos. The biggest deal is domain, range, vertical asymptote, horizontal asymptote, and then using that information to pick the correct graph. You can use Desmos to help you. Remember, the address for that is www.desmos.com. Number 5 on the homework assignment's a little bit weird. Notice the vertical asymptote is where the bottom equals 0. So you may have to set up that equation equal to 0 and solve it to get your vertical asymptote. The horizontal asymptote is the numbers in front of the x's in that equation. It is totally fine to have fractions for your vertical asymptote and your horizontal asymptote.